this example, we're asked to subtract two rational expressions that have different denominators. We've got x over x plus 3 minus x minus 7 over x minus 2. So the first thing you always want to do when you're adding or subtracting fractions with different denominators is figure out the common denominator, the least common denominator. In order to accomplish that, we've always got to make sure both denominators or all denominators are factored completely, first of all, which these are. There's no way to factor either of these denominators. So I'm going to write down what the least common denominator is here. The least common denominator is, when there's two different factors in the two denominators, the least common denominator is simply the product of those two factors, x plus 3 times x minus 2. This is what we're shooting for, to convert both fractions into something over top of. So we've got x over x plus 3. We need to multiply the numerator and denominator of this fraction here by whatever we need to form the common denominator. Currently the denominator has x plus 3 in it. It does not have the x minus 2 factor, which means we need to multiply the numerator and denominator of the first fraction by x minus 2. Okay. And I'm going to enclose the x plus 3 in parentheses there. Minus, I'm copying down the second fraction, x minus 7 over x minus 2. We need to multiply the numerator and denominator of this fraction also by whatever is necessary to form the common denominator. Currently we have the factor of x minus 2 in the denominator. We're lacking the x plus 3 factor, so we've got to multiply the numerator and denominator of the second fraction by x plus 3. Okay, I'm enclosing all of the binomials in parentheses to prepare to multiply. So let's do the multiplication here. We've got x times x minus 2, which is going to be x squared minus 2x in the numerator, all over top of x plus 3 times x minus 2, and then minus. In the second numerator, we've got x minus 7 times x plus 3. We need to multiply those two binomials together by the FOIL process. So x times x makes x squared. X times 3 makes plus 3x. Negative 7 times x makes negative 7x. And negative 7 times 3 makes negative 21. Okay. And then in the denominator we've got, I'm going to write the two factors in the denominator in the same order as the two factors in the first denominator, just to make them look exactly the same. Okay. All over x plus 3 times x minus 2. So we've got a common denominator under both fractions. There are a pair of like terms here that we need to combine prior to doing the subtraction. So I'm going to do that. I'm going to just bring the first fraction down here. We've got x squared minus 2x all over x plus 3 times x minus 2. And we're then subtracting this other fraction. We've got a 3x and a negative 7x, which makes negative 4x. So x squared minus 4x minus 21 all over x plus 3 times x minus 2. The two fractions are ready to subtract. So I'm going to write it as a single fraction now over top of the common denominator. So we've got x squared minus 2x. And from that we're subtracting these three terms here. So minus x squared minus 4x minus 21. Notice I'm enclosing the second numerator in parentheses. The importance of that is to remind me that I've got to distribute this negative sign or the subtraction sign through the parentheses on the next step and change the sign of all those terms that were in the second numerator. The common denominator is x plus 3 times x minus 2. So from there, let's see, this equals, let's distribute this negative sign to all three terms from the second numerator. So we've got x squared minus 2x, and then minus x squared minus a negative 4x, that's a double negative which converts to a positive, plus 4x. And then once again, a double negative on the 21 converts it to a positive 21. And that's all over top of x plus 3 times x minus 2. There are like terms that need to be combined in the numerator. So let's see, x squared minus x squared, they cancel each other out, which is nice. And we've got a negative 2x and a positive 4x, which simplifies to positive 2x. And then plus 21, all over top of x plus 3 times x minus 2. So it's possible that we're done at this stage. We have to see, though, if potentially we could factor the numerator and then maybe reduce by canceling a common factor. I don't think we can factor 2x plus 21 at all. There's nothing in common between those two terms. So at this point, we're done, and that's the reduced version of the result of the subtraction.